prompt caching can significantly improve the speed and cost effectiveness of large language models. Sounds good, sign me up. But what is prompt caching? Well, let me start by defining what prompt caching is not. So it is not regular output focused caching. So let me give you an example of that. If you've sent in a query and you've sent that query into, let's say, a database, maybe it's a SQL query. Well, the database is going to process that result and give you the output here. So we've got the result from the database lookup. Now, those results, they can be stored in a cache. And when somebody else makes that same query soon afterwards, well, we can just kind of skip the lookup and go directly to the result stored in the cache. Great. Now let's apply this concept to an LLM. So in this case, we have an input prompt that we've received from a user, and that input prompt is sent for processing into a large language model. And then the large language model is going to process that and send back some sort of output. We'll call this the response from the LLM. Okay, so that's pretty standard practice. But what happens if soon after another user sends in the same prompt? Does that prompt caching mean that we can just kind of skip the LLM call and just go directly to the cached response? No. What I'm describing here is actually called output caching, and it's certainly something that can be done with large language models, but it is not what prompt caching is. Prompt caching is about caching only the input prompt, only caching this part here, so that the LLM doesn't need to process it a second time. Now, to understand prompt caching, you need to understand what happens when we take a large language model, an LLM, and we send to that large language model a prompt. So this is where we are sending in a request prompt. Now, what happens here is the model computes something called key value pairs. So let's model that in the LLM here as KV pairs. And it does that at every transformer layer for every token in your input. And we can think of these KV pairs as the model's internal understanding of your prompt. So how every word relates to every other word, what context matters, what information to focus on. And computing these, it can be a bit expensive. This is the pre-fill phase that happens before the LLM actually can generate its first token of output. So what we can do is cache the KV pairs. So this here is where the prompt caching actually applies. It stores these pre-computed KV pairs. Now, for a simple prompt like what's the capital of France? Well, this caching isn't going to save much time. Processing a handful of tokens, that's cheap and fast. You don't need caching. But what if we structured our prompt in a little bit of a different way? So let's consider here a prompt that we're going to build in detail. And in this prompt, we have put a bunch of stuff. So for example, we're going to put a big document in our context window here. So this is a 50-page document. And then in our prompt, we are going to ask the large language model to summarize that document. So here is the summarize request. So now the model has to compute KV pairs for thousands of tokens across dozens of transformer layers, millions of operations before it can ever start generating that response. So with prompt caching, that processing work is getting saved. Now, later on in a new conversation or an API call, you could send that same 50-page document, followed this time by, instead of asking to summarize, we just provide some kind of different question. And the system will recognize that document prefix. It will retrieve the cached KV pairs and then only process the new question at the end. And that's a pretty notable saving in latency and cost. Now, what kinds of things can be cached? Let's answer that question. What can be cached? Well, I've already mentioned that you can put documents into a prompt, into the context window. So like a 50-page product manual or a research paper or a legal contract or anything you want to kind of ask multiple questions about, that can be stored in the cache. But another good example, and probably the most common thing that gets cached, is the system prompt. Now, system prompts are the most common use case where really every chatbot has instructions that tell it how to operate. It defines its personality and its rules and its behavior. You know, things like, you're a helpful customer service agent, blah, blah, blah. That sort of thing can be cached. And we can also put into the cache few shot examples. So when you want the model to format responses a certain way, you show it examples. And there are a bunch of other things in a prompt that could be cached as well, like tool and function definitions and conversation history. Okay, but when does an LLM know what gets cached? Well, it comes down to a technique called prefix matching to figure out what should actually be stored in the cache. So the cache system matches your prompt from the very beginning, token by token. And when it encounters the first token that differs from what's cached, then caching stops and normal processing takes over. And that makes prompt structure important for automatic caching. So let's consider a prompt structure. Let's say that we've got a prompt that has in it some system instructions, and then we're going to put a document in as well. Let's say there's some kind of 20-page manual that's here. And then, yeah, we're going to include some few shot examples as well. And then finally, we're going to submit a user question. So the user question might be like, what are the warranty terms? And we're going to use this manual to figure out the answer. Well, this structure puts all of the static content first. So when the next request comes in with just a different question, like now it's going to say, what's the return policy? The cache matches through all of this static content. Here, all of this stuff is actually inside of the cache, and we only need to process the new question at the end. But if we were to flip this around and we were to put the dynamic stuff first, put the question up here, then the cache is going to fail immediately when the question changes. You'd have to reprocess everything here again. So it's best to put that stuff up front, specifically when we're talking about automatic prompt caching. So that's what gets cached, but a couple of other notes based on prompt caching that we should talk about. One is like how much stuff to get cached. Well, typically you need at least 1024 tokens to initiate caching. That's really before caching provides any benefit, because below that threshold, the overhead of managing the cache really exceeds the savings. And also, caches don't last forever. They're usually cleared after 5 to 10 minutes just to keep the data fresh, although some can hang around for up to 24 hours. And some providers provide the automatic caching that I've been talking about here, but some providers actually require you to explicitly mark which parts of your prompt should be cached in your API calls. So these are the explicit types of caching. So that's prompt caching, and with the right use case, it's a way to reduce LLM costs and latency.